Hi everyone and welcome back, and welcome to Module 3. In this module we'll be building our demo environment and I'll be walking you through the steps required to get a multi-site VPN up and running. So this is how this module will run. I'm going to be taking a step-by-step approach to setting up the VPNs. We'll start with setting up the Azure parts, then move on to the on-premises environment, and finally make the modification to have two VPNs established to the same Azure gateway. We'll run through a brief overview of what we'll be doing and then go into the demo for each step. So I'll talk briefly about what we're trying to achieve and there will be a demo about that particular step and so on. Let's get started. We first need to set up our Azure network, so I'll show you how to do this. We need to do the following steps. Create our address space and virtual network subnet. Create two remote networks. For this we'll need to know the public IP address of the endpoints we're connecting to and the remote networks which are found at those sites. Then we'll set up the gateway. Since we're going for a multi-site VPN, we'll need to make sure we select dynamic routing. In the previous module I said that we would be using the entire Class B address space for the demo. I have since discovered that our local networks conflict with the address space. Let me explain why this is and how we can overcome it. When we set out to use the whole Class B network address space, we had a conflict with the address space which has been used in our on-premises environments. We planned to use 172.16.0.0 in Azure and then use 172.30.1.0 in our Wellington environment. This is where the conflict occurs. When we try to set up our address space, we'll receive an error saying that the addresses conflict. We can overcome this by making our Azure address space smaller or by using a totally different class such as a Class A or C. For the demo I've changed the address space to a Class B address with a /23 CIDR notation. This will still give us plenty of addresses. The range is from 172.16.0.0 to 172.16.1.254, which means our 172.30.1.0 addresses don't conflict with this range anymore. Now we have this new knowledge, let's go on and provision our demo environment. Okay, let's start the first demo. First we're going to set up the address space. To do this we'll select Networks from the left menu and then click on Create Virtual Network. Here we're going to select which region of the world we want our network to be in. I'm going to go with Australia Southeast as it's closest to me. I'm going to name our network Azure Network and then click the next arrow. This is where we configure our DNS settings for our virtual network. You can create a new DNS server here by typing in a name and IP address. This will then be saved for future use. I have already set up a DNS provider, so the drop-down menu will show the server I set up earlier. I'm going to select my DNS server I set up earlier and then click the next arrow. Now it's time to set up the virtual address space. I'm going to enter 172.16.0.0 and then select /23 from the CIDR list. Notice that when you select the notation that the usable address range on the right changes to show you what addresses are in your range. You can also name the subnet something else. For this demo I'm going to call it servers and choose a /24 for this network, as we need to keep some space left over for the gateway network. You can also add more subnets by clicking Add Subnet, but keep in mind we need some address space left over for a /29 gateway network. Now we click Next and wait for the network to be created. Now we're going to create our local networks. These are networks which can be found in our Wellington and Seattle environments. We click on Local Networks and then click Add a Local Network. Now we're going to give it a meaningful name which describes what it does. I like to use Azure to WRG to describe where the local network is. Next I'll give it a made up address such as 1.1.1.1 and then click Next. Now we enter in what addresses are in our on-prem environment. I'm just going to use 172.30.1.0 and select /24 as that's the size of the network. That's the local network done for the Wellington office. Next I'll create one for the Seattle office. We're going to need to use the New button at the bottom of the screen and select Local Network to add another local network. It's the same step, so I'll let you watch how it's done again. But take note of the differences with the name, gateway address and on-prem network. Now we're going to set up the gateway. So we need to click on our virtual network and this will open the network so we can make some changes. Next we'll click on Configure, then tick the box called Connect to Local Network. Then select the Azure to WLG local network from the drop-down box. Notice how it's automatically added the gateway network into our address space. Now we click on Save and wait for the changes to be applied. Now it's time to create the dynamic gateway. For this, we'll need to click on Dashboard and then Create Gateway. We need a dynamic gateway, so we'll select that from the menu. Now that we have the Azure network configured, we can look at connecting some things up. In these steps, we're going to cover updating our local network to use our on-premises endpoints. What we're going to do here is setting up a simple site-to-site VPN and get that working first. We will then turn it into a multi-site VPN in a later step. If you're only interested in a site-to-site VPN, this is how you set one up, as the steps are the same until you get to the last part of modifying the network configuration file, which isn't necessary for site-to-site VPNs. I'll show you how to go about downloading the VPN script. This is pretty simple, but at least you'll know where to find it. We're going to try and establish the VPN, but since we haven't configured the on-premises part yet, it's going to fail. The point of this is that Azure will automatically try to establish the VPN. Here I'll show you how you can manually connect it. So now it's time to configure our local networks with the IP addresses of our endpoints. This tells Azure where to establish a connection to. These addresses will be the public addresses of our RAS servers in Wellington and Seattle. First, we need to leave our virtual network settings page and go back by clicking the big arrow in the corner. Next, we'll click on Local Networks and then select the Wellington and the Edit button. We're going to enter in the public IP address of our Wellington RAS server and then click the next arrow. Now that's completed, we can repeat the process for the Seattle site. Now that we have both local networks pointing in the right place, we can go and download the VPN script. To do this, click on Virtual Networks and then our Azure network. Click the Download VPN script button. We want to select Microsoft Corporation, RAS, Windows Server 2012 R2. We'll save this to our computer and then copy it across to our RAS servers. We're going to click on the Connect button here, so Azure will try to establish a connection to our on-premises environments. This is going to fail as we haven't configured RAS on those environments yet. I'm going to show you this now so you know where to find the button. If you look to the middle of the page, you will see some diagnostic output. This tells us that Azure was unable to connect to our Wellington site and the time of when it last tried to connect. Next, we're going to talk about setting up our on-premises sites. Now it's time to configure the on-premises environment. In this step, we'll be setting up our local environment. We need to perform the following in order to get this working. We need to install Windows 2012 R2 on a virtual machine and then install routing and remote access services. We're going to run the VPN script we downloaded earlier, and this will configure RAS for us. This makes life so easy, as setting it up manually would take a bit of time. Finally, we'll create some routes to allow our server to talk back to our internal environment. This is the persistent route I mentioned previously in a module. We may also need to add some routes to the RAS if we decide to add another network at a later stage. We're going to need to open some firewall ports on our external firewall to allow our VPN to establish to our RAS servers. The ports you need to open are UDP 1701, UDP 4500, UDP 500, and Protocol 50. Since everyone will have different types of firewalls, I won't show you how to set these up. But in Cisco ASA, it's a case of making a service group and adding these services into it, then allowing traffic from the outside interface to the public address of the RAS server for this service group. Now on to the demo. Welcome back to the demo. In this demo, we will be configuring our on-premises environments. In the interest of saving time, we'll only be showing the setup of the Wellington site in this demo, as it's the exact same procedure for the Seattle site. So to start things off, I'll show you the network configuration so you can see what I mean when I say the server must have a public IP address. We have two adapters here which I've labelled internal and public. We'll open the public adapter first. Here you can see that we have a public IP address, subnet mask, and the public address of our gateway. Now we'll open the internal adapter. Here you can see we only have a private IP address and a subnet mask. This is because we want all our traffic by default to be routed via the public adapter. Since we want the server to be accessible to our internal network, we will need to create a persistent route. I have a screenshot of the command you will need to run in order to set this up. I'll break the command down for you. The command is route add -p network mask subnet gateway. Route add -p adds a persistent route. 172.30.50 mask 255.255.255.0 is the network which we want to access this server. The 172.30.1.254 is the gateway of our internal adapter. So this is what we would put in our adapter settings if we were not using the public IP address as our primary address. Now we'll move on to how to install RAS manually. In Server Manager, we want to go into Add Roles and Features. When we arrive at Roles, we want to select the Remote Access role. After that, we click Next a couple of times and we're asked what remote access services we want to install. If we tick Routing, it'll automatically select Direct Access and VPN. It's the same result if you click Direct Access. Next, we'll be told of some dependencies which we must install as well. So just click Add. That's the hard way of doing things, and I'll show you the easy way. We can use the script we downloaded earlier to do all the work for us. It's literally run the script and it's done. First, we need to rename the script to a PowerShell extension, which is .ps1, and then we open PowerShell as administrator, find the script and run it. The script takes a couple of minutes to run, and when it completes, it outputs an error to the screen. This doesn't mean it has failed, and every time I've run it, I get the same error message and everything works. Now that the script is run, we can jump into our Azure portal and give the VPN connection a bit of a push. Simply press the connect button and then wait a couple of minutes. Once it's connected, you will see the screen change from disconnected to connected, and that some data has been transmitted across the VPN. It is just that easy to set these up. What we currently have here is a site-to-site VPN. We'll be making it a multi-site VPN in the next demo. Now we're on to the final step, and possibly the one that will cause a number of people some troubles, but don't worry, I'll explain this as clear as I can. When I first did this, it took some time to get my head around exactly what it was I needed to do. Luckily for you guys, I'm going to explain it all to you. So in this step, we're going to do the following. We'll need to download the network configuration file, and I'll show you how to do this. It's not hard, but at least you'll know where to find it in Azure. We're going to edit the configuration file and add our Seattle office into our VPN environment, and this will be the step which creates the multi-site VPN. This is the tricky part, but once you understand what's happening, it will become easy. Then we'll upload the configuration file into Azure, and this will modify our Azure network. Once we've done this, and it has been accepted by Azure, you will no longer be able to use the Azure interface to make network changes, as you'll need to modify the network configuration file each time you have to make a change. Now on to the demo. Welcome back to the demo. In this demo we're going to be covering how to convert the VPN we created earlier into a multi-site VPN. So far we have a site-to-site established to our Wellington site, and now we're going to add our Seattle site into our Azure network configuration. Once we do this, we'll no longer be able to use the Azure portal to make changes to our network. So let's get started. The first thing we want to do is log into our Azure portal and download the network configuration file. To do this, open the virtual network and click on the Export button from the menu at the bottom, and then click OK to save it to your computer. Next, we want to edit the network configuration file. For this, you'll need your favorite text editor. We want to scroll down to where it says Connection to Local Network. This is kind of hard to see if you're not used to reading XML. To make things easier, just look for the name of the local network, Azure to WLG. Once we find it, we want to select the 3 lines and then copy and paste them below. This is our existing Azure to WLG connection, and what we're going to do here is rename the WLG to SEA for the 3 lines we just copy and pasted. If you pay close attention to the video, you'll see exactly what I mean. All I've done is copied the 3 lines, then changed the line which says local network site ref name equals Azure to WLG, and replaced the WLG with SEA. This is the tricky part, and it's not that difficult once you understand. The hardest part is finding the 3 lines amongst the XML. Now we click Save and we're done editing. Here's a tip. If you take a backup of the original file, you can restore your Azure network back to the previous configuration if you change your mind later. Now we click Save and we're done editing. Here's a tip. If you take a backup of the original file, you can restore your Azure network back to the previous configuration if you change your mind later. Now we need to import our file into Azure. To do this, open the Azure portal, then go to Networks and click the New button at the bottom of the page. Now click the Import Configuration button and browse for your modified network configuration file. Then click all the OK buttons and your config will be installed into Azure. When we go back into our virtual network, notice that we have a different screen presented to us. This shows us both VPNs and that our Seattle VPN is disconnected. So now we need to set the same pre-shared key on the Seattle VPN. Each local network has its own pre-shared key, so in order to make this work we need to set the pre-shared key of the Seattle VPN to be the same as the Wellington VPN. To do this we use PowerShell with the Azure modules installed. Here are the steps required. First we need to add our Azure account into PowerShell so we can connect to our Azure subscription. To do this, run the add-Azure account commandlet, then enter your username and then enter your username and password. Next we need to get the pre-shared key of the Azure to Wellington local network. For this we run the command get-azure vnet gateway key -vnet name Azure network -local site name Azure to WLG, and we pipe that to select value. This will return the pre-shared key. Next we run set-azure vnet gateway key -vnet name Azure network -local site name Azure to C -shared key. We put the pre-shared key which we just got after -shared key, and then it will set the key on the Azure to C local network. Now that we have the connection set up correctly, we can now tell RAS to connect. This is done by simply opening the Routing and Remote Access in Server Manager and then clicking on Network Interfaces and right-clicking the Azure IP address, then clicking Connect. Now we can see the status has changed to Connected. We can verify this has happened in the Azure portal by going into our virtual network and then refreshing the page. You will see that the Azure to C has changed from disconnected to connected. Now we have a single Azure network connected to multiple locations, which is going to make life a lot better for a lot of organizations. Next we're going to be talking about monitoring our VPNs. There will also be some more demos.